Okay, this is part 2 of our review. We're going to move on to a number 11. Now, a number 11 in our review for chapter 4, we have two fractions, 1/5 plus 1/10. First thing I do, I look at it and I'm like, my denominators are not the same, so I cannot add those. So the first thing I need to do in step 1 is find my lowest common denominator. So how I do that is I have a 5 and I have a 10. So I start thinking to myself, okay, well, 5 times 1 is 5, 5 times 2 is 10. Up there you go, because 10 times 1 is 10. There is the lowest common denominator, lowest common multiple. So now that I know it's 10, step 2, what I have to do is find my equivalent fractions. So equivalents. All right, and sorry that's scribbled in there. So equivalent. So how I do that is I go back over here to my original fractions. So I have 1/5, and then my next one is 1/10. So I'm going to write equals, and I know I want these fractions. In order to be able to add these two fractions, I need this lowest common denominator, so I'm just going to write those in. I determined that up here in step 1. Okay, now I'm going to start asking myself, okay, what times 10 equals 10? Well, 1 times 10 equals 10. So what I do at the bottom, I'm going to do at the top. And 1 times 1 is just 1, because we're not changing the value, we're just changing the appearance. And 1 over 1 is a fraction, is really just multiplying 1/10 by 1. So we're changing the appearance, not the value. So now we go over here to 1/5, and I ask myself, okay, well, 2 times 5 equals 10. So what you do at the bottom, you must do at the top. So 2. Now I just came up with my equivalent fractions, and they now both have the same exact they both have the same denominator now. So I can go ahead and take those numbers over here, and I can now add them. So now I have 2/10 plus 1/10, and we learned that we could just rewrite that as 1 fraction over 10, and that would become 3 over 10, and we cannot simplify that any further, and that is our final answer. So again, the process when you're adding these two up, if you do not have the same denominator, then you're going to have to go through step 1 to find your lowest common denominator. Then in step 2, we're going to come up with our equivalents, and in step 3, we're going to go ahead and add them up. So this was step 3. Sorry, I'm scribbling that. But let's go ahead and try that again with another one. So let's clear that out. And let's try this process again. So now in number 12, we're doing the same thing, but it's going to look a little bit different. So if we have, oops, let me make that a little bit larger. Okay, so in number 12, we have 6x all over 35. And we're going to add that to 3x over 7. So the first thing I start asking myself, are these the same? They are not. So I need to go through and find my lowest common denominator. And we can already see it's going to be 35, but I'll just show you the process. So 7 times 1 is 7, 7 times 2, 7 times 3, 7 times 4, and then 7 times 5 we know is 35. And a 35 times 1 is just 35. So right there it is. There's our lowest common multiple, which is our lowest common denominator, is 35. Okay, once we find that, now we come up with these equivalent fractions. So I'm going to go over and I'm going to rewrite these fractions. So I have 6x over 35. And we know the lowest common denominator, right there, 35. I'm going to set it up in my second fraction with the 3x over 7. And this one's 35. So again, we're just changing the appearance. We're not changing the value. So I have to ask myself, well, what times 7 equals 35? Well, we know 5 times 7 is 35. What happens at the bottom must happen at the top. So that would be 5 times 3 is 15. Don't forget your x. And then 1 times 35 is 35. What you do at the bottom, you do at the top. So 1 times 6x is just 6x. All right, now that we have these, we have this one, and we have that one. Now we're going to go over here. Our original operator was addition, so we're going to make sure that we add those two up. So I'm going to rewrite them over here. So 6x over 35 plus 15x over 35. Now I'm going to rewrite that as one fraction, and rewriting it as one fraction, you just move that up a little bit. So that would be 6x plus 15x all over 35. Now I'm going to evaluate this. Since they have x's, they are alike and I can combine them. However, if it was something like this, that would not be the same. It's not common, so you would not be able to add them. They would be in the final form. But however, our problem has 6x plus 15x, so we're okay. So we can go ahead and add that up. So when we add that up, our final answer would be, oops, let me go back in black, 21x over 35. But when I look at it, it's not in simplest form because I can already see that 7 times 3 is 21, and then 7 times 5 is 35. So I'm going to write that out as 7 times 3x all over 7 times 5. So now I evaluate. There's a 7 on the top, a 7 on the bottom. That converts to 1. And now my final answer is 3x over 5, and that is in simplest form. So when you work on your quiz, this is probably going to be the most work, is when you start the initial problem up here, you're going to have to evaluate to see if they have the same common denominator, and if they don't, you're going to have to go through this 3-step process where 1, you're coming up with the lowest common denominator, 2, you're coming up with your equivalence, and then once you have your equivalence, 3, you're going to go back and perform the original operation, whether it be subtraction or addition. And then you're going to have to make sure that 4, you got to make sure it's in simplest form before you come up with your final answer. All right, so let's move over to number 13. Okay, number 13. Now you're going to have something that's called a complex fraction, which looks like this. Oops, let me go to black. Now it's going to look like this, but don't let it intimidate you. So you have 3/8 all over 3/7. As soon as you see that, just immediately understand that this right here means division. So I would just rewrite it. So if you rewrite it, it becomes 3/8 divided by 3/7. And the rule states when we have a problem like this, we convert this to multiplication, and then we take the reciprocal of this number. So I'm just going to rewrite it as 3/8 times, and remember, flip this next number, which is 7/3. Once you do that, I just rewrite it. Oops, sorry about that. I just rewrite it as 7 times 3 all over 8 times 3. And you can immediately see we have a 3 on the top and the bottom. That reduces down to a 1. So our final answer is 7/8. It looked very intimidating when it was in this format, but when you look at the actual process and the work, it's not a complicated problem. It's just a matter of rewriting it to get the correct answer. And that was number 13. Okay, let's move on to number 14. So let me clear that out. All right, this is number 14. All right, now number 14 looks like this. 7/9 divided by 1/3 times 1/6. All right, so I'm only going to do 2 at a time. So I'm going to get the answer for that one first. So remember, to do that, it must be, we're going to rewrite it as a multiplication problem. So 7/9 times, and make sure you get the reciprocal, 3/1, flipping it. And I'm going to equals, and I can immediately see, before I rewrite it, I can see that I can get a 3 times 3 out of the 9. So I'll rewrite it like that. So 7 times 3 over, now the 9 would be represented as 3 times 3 times 1. I can see that I have a 3 on the top and the bottom. That reduces down to 1. And then I can write it as 7 over, oops, sorry about that. Let me rewrite that. 7/3. Okay, now that's the portion for the green, stuff in the green. Now we need to be concerned with the 1/6. So now I'll take this 7 over 3 and I'll multiply it by 1/6. And we just know if we multiply that across, it's just 7 over 18. And we cannot reduce that down any further. And let me go ahead. Okay, now let's move over to number 15. How am I doing with time? Okay, I think I'm okay. So number 15, now number 15 is taking a whole number times 3 1/3. Now the first thing I would do, just remember when you come up with your final answer, we're going to finish it in that form. But for now, I'm going to write it as 2 over 1 times, and then remember 3 1/3, to convert that, that would be 3 times 3 plus 1, all over 3. So that would be 10 over 3. So I'm going to write it as 10 over 3, okay, and that equals, and it doesn't look like we can reduce it down any further, so it would be 20 over 3. Now, even though this is our final answer, can't reduce it, remember we want it to come back in that form. So to do that, I'm going to convert that into a division problem. So 3 into 20, and I start evaluating. I'm like, how can I get close to 18 or to 20? So we know that 3 times 6 is 18. And you subtract that, you end up with 2. So it would be 2/3. So my final answer, instead of leaving it as 20 over 3, it would be 6 2/3. Just read your set of instructions. It'll let you know what kind of answer it wants, whether it wants a mixed number, whole number, decimal, so forth and so on. But just make sure that you understand in Chapter 4 we're working with all fractions. Chapter 5 we're going to move in on to decimals. Okay. Sorry, just keep checking my time. So that's number 15. So I'm just going to stop here, and it looks like I'm going to need a part 3. And then so this was number 15. And then I'm going to pick up on the third part, and we'll do 16 through 20. That'll be the remainder of our problems. Actually, let me do number 16, and then we'll move on to the next video. Okay, so number 16. That is a whole number like this, and 2/5, and then we have 6 and 11 over 15. So the first thing I have to ask myself, I'm sorry, there's not enough time. Let me go to the next video.